Hello everyone, how are you? This is Prashant here again, and we are back with our Snapper blockchain masterclass. And today I'm really very excited to talk about Ethereum. So we're going to learn about what Ethereum is. We're going to get into the details behind the Ethereum technology and the entire vision behind Ethereum, the folks, most importantly, and the most amazing feature of Ethereum, its applications and its use cases, right? So I hope you all had a very good time, understanding blockchain in our previous master class. So let's talk about, Ethereum. And first of all, thank you so much for all your support to the Snapperverse. And we have received fundamentally, very fabulous response for, Snapperverse. And as a giveaway, and to give it back to the community, I'm going to give away $50 worth of free Bitcoins. Yes, you heard me right. $50 worth of free Bitcoin for the ones who will kind of comment below, who's gonna, why you love Bitcoins and why you love Ethereum, right? So just comment below, and at the end of my 25 master classes, I'm going to give away $50 worth of free Bitcoins to one best comment. So let me know why you love blockchain. Let me know why you love Bitcoin. Let me know why you love Ethereum. And also you can post which is the best crypto you feel, and what are your comments about the blockchain and cryptocurrency. So let's dive into the Ethereum, right? And let's say what our AI analytics say first of all. So let's get a brief idea about Ethereum, right? So Ethereum is right now trading third top crypto coin, just behind Ripple, and I think it's just very little gap between, so the market cap of Ripple XRP is $13.57 billion, and Ethereum is about $13.21 billion. And the number of coins available in circulation is 104.314 million, around 104 million. And the peak of what the Ethereum has went is somewhere about $1,500 last year when along with the Bitcoin. But if you understand, the total circulation of Bitcoin is around $21 million, but Ethereum has no such cap on the limitations of circulation, right? So there could be unlimited number of Ethereum based on the mining block reward. So the block reward for Ethereum is currently at about 3 blocks. But unlike Bitcoins, right? So the last Bitcoin is going to come into existence in 2140, because as I mentioned to you about that, Bitcoin doesn't just want to be the peer-to-peer currency or peer-to-peer money, but which is basically has all the properties of money, like it is limited, and also it is divisible, it is movable at the less cost possible, and also most importantly, it is basically prone to inflation like your traditional money. So basically what happens in the Bitcoin blockchain, since it's based on proof of work, so what typically happens is that there's a halving effect. So the block rewards gets halved every 4 years. So based on this calculation, the last Bitcoin or the 21st million Bitcoin will come in existence in 2140. So there's going to be a halving effect every 4 years. So we can calculate the last halving effect. The first halving effect was in 2013, and the second is 2017, and the next halving effect is going to be 2021. So the block's going to get reduced basically by half, and that's the most amazing part about Bitcoin. So I think that feature is not there in any of the cryptocurrencies, right? And also Ethereum is basically based. So Ethereum is also a split of Ethereum Classic. If you understand Ethereum Classic, because of the controversies between the founders of Ethereum, and so Vitalik moved out of the Ethereum Classic, which is supposed to be the original Ethereum, and created Ethereum. So there's a lot of controversies behind it. So let's not get into that. Let's try to understand Ethereum more in detail. Let's just have a look at what are trading technical analysis say about this, right? So it says sell for Bitcoin, and even sell for Ethereum, and even for Ripple, and even for Litecoin. So friends, first of all, this is not an investment advice. I'm not an investment professional. So this is just purely based on the recommendations and the algorithms behind this platform. So this is not an investment advice. So if you're trading, buying, selling, you're doing it at your own risk. So let's kind of dive into its technical, graph. So Snapperburst provides very wonderful ways of analyzing things. So I can just here and search for, Ethereum ETH. So ETH USD, right? So ETH USD. So basically the Ethereum has fallen from a peak of $154 about a day ago to just $123. I don't know why there's been some, sharp decline in Ethereum along with all cryptos. So let's see its 5-year performance. So as you could see that, Ethereum was at peak about 1,500 US dollars on Kraken in around December last year. And we basically, provide the wonderful graphs. So you can have all kinds of folk if you're an analyst, right? We give you all kinds of folk from pitchfork to, FIB channel, FIB wedge. So if you're a professional trader, you can also use paintbrush to, customize and to draw lines and to kind of have an in-depth wave analysis. And also you can kind of put text box your comments, and if you need some other in-depth analysis, like you're looking for patterns, so we also provide you patterns without you being kind of told. So Snapperbuzz altogether, the whole idea is, as I mentioned to you last time, is basically to, cater to both the readers and also the whole traders. So we provide in-depth tools because we understand that you are a trader and you need a lot of analysis and customized tools to do that. So we provide a very, very beautiful way of analyzing this. So without, just let's dive into Ethereum. So I'm on ethereum.org and I'm going to share the links of this below. So you can just go through the Ethereum. So the Ethereum says itself that it's a blockchain application platform. So what do you mean by that? So basically Ethereum was the first blockchain to kind of create decentralized apps, to create a vision for decentralized apps. So you might be wondering, why the world needs decentralization? What's the key difference between the centralization and the decentralization? And what makes Ethereum, so special? So basically the whole idea on Ethereum is that you can build applications, decentralized applications on the top of that, like you can custom build. So there is no third party, there is no centralization, and there is no basically abuse of power. So all the applications would be run by a decentralized Ethereum network. So it's a peer-to-peer application network, and it also has its own token called Ethereum ETH. So which they call the smart money and the smart wallet. And the best part about Ethereum is that you can also kind of launch your own tokens or your own cryptocurrency. Let's say I can launch my Prashant coin, or you can launch your own coin based on your idea, and you can have your customized smart contracts. So what is this smart contract? So this smart contract is a very wonderful feature in Ethereum. We're going to dive into the smart contracts and applications in detail. And basically Ethereum is based on a programming language called Solidity, and they have their tool called Remix Solidity, with which you can basically code and build your apps on the Ethereum. And you can also, so as I said, design and issue your own cryptocurrency or a tradable token. So what's the biggest advantage of this? So majorly Ethereum is traded on all crypto exchanges. So if your tokens, or if your token is based on Ethereum ERC20, right? So it's very easy to get listed on the exchanges, and it's also very easy for the investors to hold, because they can hold it within their existing Ethereum wallet. So the token standard is called ERC20. Similarly, Ethereum has around 3 token standards, which also we're going to learn more about what is ERC. So Ethereum is currently based on proof of work. So the miners has to do mathematical calculations, and they have to perform certain tasks in order to get rewarded. But now they are moving to proof of stake to have scalability, and even Bitcoin is moving towards a Lightning network to have faster transactions and bigger block sizes, and so on. So we're going to also we're going to also understand the difference about proof of stake versus proof of work, and why Ethereum is moving towards the proof of stake. And also the forks. So there are a couple of forks, which is called the hard fork and the soft fork. And there's a Constantinople fork up in the middle giant somewhere for Ethereum. So we're going to also have a little bit, I'm going to also explain about the forks and the latest Constantinople fork. And so basically you can, on Ethereum platform, you can basically kickstart a project with a trustless cloud sale. So what do you mean by that? So basically Ethereum uses smart contracts, right? So with smart contracts, you can basically, kind of issue or own tokens. So let's understand what is a smart contract, right? So smart contract is basically a predefined business steps which is stored in a contract and which can basically have an enforceable transaction. So what do you mean exactly by that? That in smart contract, let's say a party A and a party B wants to get into a contract, and so you can define all the terms of the contract, and it is backed by a escrow. So let's say, for example, let's take a small scenario of a crowdfunding which they are talking about, right? So you can create your own token, and let's say if I'm raising money for my venture, right? And in exchange for that, I give you the tokens. But how would you trust that after you give me the money, I give my tokens or I give my security to you, correct? So with the smart contracts, it's an auto-executable or a self-executable contract. So I can put all the terms and conditions of a contract. Let's say my soft cap, which is the minimum capital I am looking forward to raise, and my hard cap. Let's say my soft cap is about 1 million and my hard cap is like 100 million. So if during my crowd sale campaign, if I receive any funds less than 1 million, right? Which means that the conditions of the contract are not met, and practically and possibly my fundraising or my business model is a flop, right? So all the money to the investors who have invested would be automatically returned back without having a third party or escrow service. And the best part is that nobody controls this. This is a trustless. And let's say my hard cap is 100 million. So if I receive any single dollar more than 100 million, also the money would be returned back to the user. So it could be decentralized, and you don't have to basically trust some Kickstarter or any middleman or an escrow service to ensure that the money is put in the right place. And also the contract is visible to everyone on the Ethereum network, so you can just put the address of the contract and you can see the codes and everything behind it. So it's 100% kind of transparent, and also it can basically remove the middleman. The whole idea is that. And also not only that, you can but also create a democratic autonomous organization. So what do you mean by that? Like you say, after you have developed your idea and you have secured funds, right? So need a trustworthy traditional CFO to handle the accounts and run board meetings and do a bunch of paperwork, right? So you basically trust the CFO and the lawyers in organization structure. But what Ethereum says that all you have to do is just trust the smart contract. So you can put all the parameters or all the roles and responsibilities of what a CFO does onto a smart contract, and then based on the various parameters, it gets executed automatically without relying on some CFO. Right? So it's very cheap, and most importantly, it's super safe, because we see a lot of scams being done within an organization, and also it could also have a very transparent voting process. So imagine like whatever vote you give, that's get recorded in an immutable way, right? And it gets self-executed. So all your votes will be also recorded, and everything will be recorded, and everything will be visible to the community. So traditionally, if I raise money through a crowdfunding campaign, the community doesn't know anything about it, right? They don't know how the voting structure is or how the organization structure is. But if it's governed by smart contracts in Ethereum, so community would know each and everything, like what's going on and who voted what and how's the money being utilized. So it's completely transparent. So this is the whole idea. And not only that, you can basically build entire world of decentralized application. Let's say you can build a decentralized exchange, a decentralized escrow service, a decentralized ticketing system. So the whole idea is basically to promote shared economy. So let's understand what shared economy is, right? So this is the Ethereum white paper on the GitHub. If you want to get more into the detail and understand the vision, mission, and the total roadmap for Ethereum, I'm going to also share the link of their GitHub into the section below, so you can just have a look at that. So basically, what Ethereum says is that so basically, like Bitcoin, right? You cannot kind of develop or deploy your own codes or your own applications on a Bitcoin network. Well, you can do, but it's slightly difficult because their language is kind of little bit difficult. So there's a very less community behind the language, and basically it's a little difficult. So you have to fork. If you have to launch your own things on the Bitcoin, plus it's based on ASIC mining, whereas Ethereum is basically based on GPUs and CPUs. So they have a layer called Ethereum virtual machine. So it's like a decentralized network of computers, unlike Bitcoin, where you have just decentralized of miners, which is purely based on ASIC. So ASIC is nothing but, it's based on zeros and ones. So this is introduction to, basically, why there was a need for Ethereum. So they have given a brief introduction to Bitcoin in the white paper and existing concept, the history, Bitcoin as a state transition system, the mining. So we have understand Merkle trees in my previous video, and what are the alternative, application mining. But now they talk about the Ethereum. So the philosophy of Ethereum, the Ethereum accounts, and how the messages and the transactions are handled, and the code execution, the mining, their applications, their conclusion. So basically they keep on, editing. And if you understand and if you go through, right, so Ethereum is a decentralized foundation. It's just basically incorporated in, basically Switzerland, and Vitalik is basically kind of the, chairman of the foundation. But unlike, any other blockchain community, or any other blockchain protocol, you can basically Ethereum hears the voice of all the people engaged in the community. So you can give actually your feedback, your comments, if you want to improve or if you want to add, and then they have a kind of a voting system or a consensus what change in order to go through. So it's a very, very transparent and open and a huge community. So I would say currently Ethereum is the largest, it's a protocol with the largest blockchain community worldwide, because more than 99% of the tokens or the ICOs we heard about is purely based on the Ethereum network. So it's by far the most powerful community we have seen. And since it's based on proof of work, it has some scalability issue, as I mentioned, and now they're transitioning to proof of stake concept. So basically they have Vitalik Buterin, he's a most amazing visionary. And I really admire Vitalik and his vision and his mission and what he wants to bring to the network, right? And he basically leads the Ethereum team and So let's understand the mission and the vision statement, right? So the Ethereum Foundation's mission is to promote and support Ethereum platform and base layer research, development, and education to bring decentralized protocols and tools to the world that empower developers to produce next generation decentralized applications. So you might wonder why the world needs DApp, right? So just let me, take you to a small, kind of a understanding about the Ethereum. So the Upfolio has basically created a very wonderful kind of a guide on Ethereum, a very basic but really, really wonderful and really, really expressive. So I'm going to also put their link, so maybe you can just go through and refer that. And so the whole idea behind Ethereum is to basically build the whole idea behind Ethereum is to basically build decentralized applications. Sorry friends, I had actually someone, waiting for me. So just a small, interruption. Basically, I was talking about the mission and the vision statement, and the Upfolio has basically created a very, very, wonderful guide on how Ethereum works and why it is, so revolutionary, right? So let's kind of, go through the guide and understand why there's a need for decentralized application, and on the whole, why there's a need for Ethereum and what problem does Ethereum solve. So now, let's say that, you need to understand, first of all, how the internet works today. So internet is very revolutionary. It has created the greatest value to the humankind. And I think, as I mentioned earlier, the internet for today suffers from issue called trust. And I think the trust is the biggest value creator for the entire human race, right? And we just don't need trust when it comes to a transaction or moving money, but we need trust in our day-to-day lives. We need to trust lawyers, we need to trust bankers, we need to trust service providers. So there's a whole bunch to this, thing called trust. And Ethereum basically, or the blockchain, brings trust to the entire internet. So basically, currently, if you give your personal information like your name, address to a company online, that information is basically stored in their computer system, which is called a server. Now, these servers are basically, kind of centralized, and meaning that they have the access to basically kind of read or record your photos, or they basically record your photos, your emails. So they know who you are as a person. There is no privacy anymore because they have access to all your data. And then they sell this data, through a lot of big invisible network all around the world, and then they make money, right? So this is how things happen. And the other one of the biggest reason is that since these centralized systems are, mostly operated by a service providers called, Microsoft, Google, or, Amazon, So basically, yes, definitely this way of doing things is like very, very convenient, right? But it has two biggest downsides. First is basically, hacking. And obviously, second is that your personal information is no longer personal anymore, right? Because since it's stored in the Google or Amazon's or Microsoft server, they basically have access to your data. They have access to everything. And we all know that data is the new oil, and they basically monetize on the data. So they monetize on the data, and this hacking happens, all the times. So the biggest example, some of the biggest hacks is basically Facebook, Analytica, Uber was hacked, Dropbox was hacked. And also, let me also explain it to you that the biggest problem with this traditional data centers, right, or a centralized system. So they definitely do have backups, multiple backups, like 2, 3, 4 backups at multiple servers or at multiple locations, right? So you can obviously say that, okay, if one server is down, doesn't matter, you always have another one to back it up. But this is what makes this computing very, very expensive. So the cloud computer is like super expensive because they have to maintain this whole, data centers and stuff like that. But whereas on the Ethereum network, right, because since it's a peer-to-peer computer network, I'm contributing my computer to Ethereum network in exchange for some Ether, which is basically the monetary converted. So I have my whole cost of the infrastructure or the computational power which I'm providing. It is creating a sharing economy as on a whole. So I get paid back in Ether. So it's how wonderful it is, right? You have a computer which is just lying, and you can just contribute to the network and you can just earn money. So the whole idea is basically to promote sharing economy. Like today, Google uses all your data, but it doesn't give you any money, right? He said he just wants to take more and just use it for their own personal use. But what if, on the Ethereum, you can basically, for the first time in the history of the world, there is a concept called shared economy. You could basically practically just lend your computer network, just plug it to the internet and just make sure it has power, and you could basically earn money, right? So this is the whole idea behind that, and that too without having any third party. So it's creating a trustless ecosystem where the blockchain is establishing trust among the network, and you are able to earn money. So now your personal information is encrypted, as we learned about in blockchain, that all the information which is stored is kind of encrypted, which means only the one with the password or the authority have access to that. And now no longer, let's say in a blockchain world, if let's say Google wants to access your data, right, they have to take permission from you. And it's totally protected. Isn't it amazing, right? So it will basically gonna save internet from all this manipulation. All our searches are like always manipulated. Google and Facebook tries to promote things which are paid and things like that, right? Not based on the feedback. So this is the whole idea or the whole reason why the world needs Ethereum, right? For two reasons. One is basically it prevents everything from hacking because it's a decentralized network. So no hacker would know where your data is actually stored because your data is distributed. Second is that it basically prevents your personal information. And the most importantly, above all, the biggest advantage is basically it will make in the long run the computational power much more cheaper. So I think, tomorrow, if you just go back a little, right, we consume more and more data, and with technologies like IoT and AI coming into picture, right? So what could be the biggest threat for AI, right? So I would always wonder, right? I'm really much inspired by sci-fi movies. So my first startup was also, the Snapper. The whole name basically came from our first image search engine, which is basically on AI powered. So let's say if I like your watch, I like your shirt or anything, and I could just take a picture of it, could just do image analytics and tell you what price it is available on the internet. But now you imagine that tomorrow the world's gonna be run by IoT devices, like your car's gonna be self-driven, you have robots working with. And let's say if these all things are running on a centralized server, one, which means that we're gonna need more and more computation power to support this. Two, the biggest advantage is hacker. We have seen movies like Terminator and shit like that. So basically what's gonna happen is that let's say if one guy just attacks on a central server, all the robots can be turned into an evil machine, right? But with the blockchain, imagine that all these robots and everything is protected, right? right? So if they have to hack one particular thing or a particular robot, which means they have to hack the entire network altogether, which is almost impossible because the network will have millions of computational power. And two, since you're going to consume more and more computational power, it has to be actually cheap, right? Because if it's on the cloud or AWS, it's going to be like super expensive to consume. So if it's on a decentralized or a distributed network, it's super cheap. And three, what if someone, let's say they Google, right? So let's say Google has a client who wants to know who you are, wants to access your data. So you're going to be actually paid if you want to share your data. So it's creating a win-win scenario for the whole world. It's creating a security, it's creating economy incentive, and also most importantly, it is providing huge computational power. It's providing energy to support all your future applications. So I think this is the power of decentralization. I think this is the power of Ethereum. By far, it is, I think, the largest, computational network. I think it's even bigger than Bitcoin in terms of computational network, right? So basically, and so as I mentioned to you about that, instead of using big computer system of a big company like Google, which is centralized, Ethereum lets software applications run on a network of like any private computer. So the computers, the cloud servers are basically replaced with large network or a decentralized network of small individual computers, basically, which are basically run by all the volunteers across the globe. So me, if we have a computation, we can just pull it or we can just connect it to the network, and we can just basically support the Ethereum network, and we can also earn money at the same time. So basically, also like the simplest example is that if you basically scroll through any app store, like like your Google Play Store or your Microsoft Store or Apple App Store, right? So since the Google or the Apple, they basically have authority to which app to promote and which app to reject, right? So whatever you see is basically manipulated by all these companies, right? And basically your choice of apps is controlled by all these third parties. So if these companies don't like the apps or it's against the policies or threat, they will just basically ban them, won't allow you to do that. So like recently, Apple has said that you cannot have the mining applications on the cloud or on the app, not on the cloud, I'm sorry, on the Apple App Store. So you have to take special permission. They're going to review your codes and things like that. But on the Ethereum, nobody can block it. You can just put your network on the Ethereum network, and you just have to pay a small incentive in terms of cash or something like that. Gas, so to basically run it, right? So basically, in short, the community of users is in charge. It is for the community by the community. That's what the power of decentralization is. So you can basically think. So basically, the big idea behind Ethereum is to create a decentralized network of computers. So where you don't need any permission and no third parties are basically required. Because trust is established by itself. You don't need a third party to verify your apps. It's open source. Anybody can run it. Plus, it's decentralized. So you can basically think Ethereum as a technology platform which would let anybody to publish and run their apps. So they don't use a centralized service or a centralized server like Google or Apple or Microsoft. So this is one of the most amazing things behind Ethereum. And also, most importantly, so many of you might have think that, okay, what if, Ethereum is controlled by Vitalik or his group of community? No, it's not basically controlled by Vitalik and not is any community. So it's just the foundation of the improvements in the Ethereum network is controlled by the miners and the Vitalik in the community, but not the data, because Vitalik itself doesn't have access to the data because the data itself is encrypted before it's pushed onto the network. So nobody has the access to the data. Not even the government or anybody can basically read what's stored on the Ethereum network. You could basically see the hash addresses, the contract, and the tokens and things like that. But basically nobody could access who sent these messages and things like that. So because the Ethereum users are located all around the world, the computer networks are distributed. It's a peer-to-peer computational network. So there is no central control, right? So this is that, so none of the users also know each other in the community, but still they are able to establish trust. And how is something which we will going to see possibly, below. So as I mentioned to you about that, Ethereum is a decentralized, or Ethereum is a blockchain application platform. So the entire vision behind Ethereum is to create a world computer. A world computer, which is a huge network of private computers that run all the future applications and without any third parties like Microsoft or Google, right? So it's actually reinventing totally. It's pioneering how internet works. It's pioneering the trust. It's basically taking the power from all the big companies and getting power back to the community. So this is the most amazing idea behind Ethereum. So it's a whole idea behind the blockchain, not only Ethereum as such, right? But Ethereum is one of the platforms which is making it happen. So, basically removing the third parties, as I mentioned, you will have potentially a lot of benefits. And I think a lot of companies will be disrupted. So definitely, big companies will hate blockchain because it's like taking away the power from them. It's taking away the money from them. It's taking away the power from them. So definitely they're gonna hate it. They're gonna not liking it because if you have seen and studied the entire internet cycle, right, basically a lot of companies went bankrupt because of the invention of the internet, because of the invention and the pioneering and the innovations in the technology. So the companies who is not, or the organizations are not able to keep up with the pace the internet is moving, they have basically forced to gone, bankrupt. So if you take my opinion, like, if I talk about the 1990s bubble, that a lot of companies went bankrupt and shit like that. Basically, I think it's not the market, it's the companies, because they weren't able to adopt to the situations of what consumer want. Right, they weren't able to adopt to the evolve of the internet, because the internet evolved so fast. So we could only see the companies like Apple, Microsoft, Google, Amazon, Alibaba to survive the entire cycle, PayPal, because they always knew what consumers want. They always upgraded themselves with the technology. So I think, and the most important thing is that they wanted to survive. They want to give best consumer satisfaction. So all the companies, even Yahoo, who survived the bubble burst, they are like one of the biggest companies in the whole world. So it's not about the bubble. It's about how you upgrade yourself with the technology. Because technology is like the ocean, waves of the ocean. You just have a lot of waves coming and you have to learn how to surf on them or how to dodge them. And you need to know which is the good wave and the bad wave. So the companies which were totally focused on its customer satisfaction, which upgraded the technology, survived. So I think this is the whole vision and the need why Ethereum works. So now let's understand how Ethereum works. So now we know why it exists. Now we have to let's understand a little bit that how Ethereum works. So let's take a simple example here. Like say, imagine there are two people who want to send messages on their smartphone. So traditionally, you would use messaging services like Facebook Messenger, WhatsApp, or Skype. So basically, it is centralized, and all your messages will basically go through their servers and then the receiver. So there's a sender, the servers, and the receiver. So which means that these companies know what kind of messages you're sending. So they would basically have access to read your messages and use them for their personal benefit or to make money. But now, because of a lot of privacy laws and things like that, you have alternative messaging services like Telegram, which is like end-to-end encrypted. Even Telegram cannot have basically access to what users are sending, and even WhatsApp has started to encrypt it. So this moment of encryption and privacy has already followed, which is also forcing these tech companies to kind of adopt it, to stay in the business. So in the Ethereum, what's going to happen is that, if let's say two people wants to send two messages through a decentralized or through an Ethereum network, since it's not run by a community, it's basically run by a network of computers. So if someone's have to send a message, first it gets encrypted. So the entire job of the miners is basically to protect or to secure the network by, solving the computational problem and to, basically secure the network and to encrypt it. So the miners would basically verify and authenticate the messages, and then the sender and then the receiver receives it. So which means that there is no third party. Your data is basically encrypted and stored in your Ethereum network. And if let's say you want to access it, they have to take your permission. So only the sender and the receiver would basically have access to the, to the data. So you would require a password, or you have to authenticate that is to you who have to basically send the messages. So the whole use case is basically not just that. So basically, these apps would basically work automatically because they, without any middleman, because they use smart contracts. We just understood a little bit about the smart contract, but let's try to understand more that how the smart contracts works by taking more examples. So basically, what in smart contracts, every party A and party B could basically define all the rules of the contract or the rules of engagement. right? And it's time-stamped and immutable. And since nobody could basically go back that, hey, I didn't have access to the data. So traditionally, let's say if I'm entering into a contract, so let's take a scenario of buying a house, or, let's take a scenario of buying your smartphone, right? So let's take any scenario. So typically the exchange would work is that I pay you the money and you get me the phone. But when you're buying the phone, the manufacturer commits you, or if someone commits you a lot of warranties, right? But the warranties has again a lot of terms and conditions and things like that, right? So what if the money is basically first of all locked in the escrow? So which means that the sender or the supplier doesn't have to worry about the money, because the money is already kind of locked in an escrow and it is governed by no one. So I just cannot go take out the money. So technically in the capital markets or in the big financial markets, if you see the whole scenario, there is something called swaps, which is called the vanilla swaps. Just take an example of vanilla swap. So what happens in a swap is basically that, let's say there's a party and a party B. Let's say a party A says that if the interest rate goes up, he bets on the interest rate going up, and the party B bets on the interest rate going down. So this contract is basically kind of follows the LIBOR rate, which is London Interbank Exchange Rate, right? Or rate. So if the LIBOR goes up, the party A has to get some $X. Let's say the contract is for like $100 million. Now the point is that before these parties enter into a contract, the contracts are facilitated by banks like Goldman or JP Morgan. So these banks act as a center for trust for party A and party B, because these banks establishes the creditworthiness of party A and also the creditworthiness of party B. Because in terms, let's say the contract expires, let's say after 6 months, someone has to pay money to each other. But what if someone collapses, or what if someone defaults? Like we have seen 2008 crisis, like Lehman Brothers going down and $trillions of dollars just goes up from the market, correct? Because they cannot establish credit worthiness. It's just that after a point of time, a central bank takes a guarantee, or some middleman takes a guarantee that he pays. What if it doesn't pay? So in a smart contract scenario, what's going to happen is basically that the money is going to lock in, and the smart contract is going to study the entire credit history. So everything is basically connected onto a smart contract, right? So your credit history, your bank balances, and everything. In terms that if any of the parameters gets executed, the movement of money happens real time without any money, without any middleman. So it's like super cheap. So you don't need like central banks anymore to establish trust. It's just the technology and the contract establishing the trust. And contracts is something which we do use it in our daily lives. We use it with the consultants, we use it with the lawyer, we use even when we are surfing the internet, like the terms and conditions. The smart contracts are pretty much like used everywhere. So also, let's take a small example of a baseball game. So let's say the contract is smart, it can basically act by itself on certain laws. So could be connected to a weather app and and also, basically, so let's say, for example, in ticket scenario, right? So there's a refund policy. So the refund policy is that if the match gets cancelled, everybody should get their money back. So let's say there is a rain. So this smart contract is connected with the weather app. And as soon as the rain starts falling and the event gets cancelled, all the money is distributed back to the ticket holders without worrying about anything, without they worrying about it. So they don't need a event. So it's creating a win-win ecosystem, not only for the businesses and the consumers, but also for everyone in the ecosystem, because you don't need visas and the Mastercards to kind of distribute it. Plus, it's real time. So typically, if I use a credit card or a debit card, after I use it, it literally takes some time for the money to actually get settled into the vendor's account. But with the blockchain, it could be like instant and a real time, and also the refunds could be also real time, because we use this amazing thing called smart contracts, which is a programmable and self-executable contract. So a lot of but the whole thing is that in the smart contracts you need to have a certain monetary system, and these monetary systems can only be used using Ethereum. So you cannot basically kind of connect with Bitcoin, the Ethereum smart contracts. Since the whole ecosystem has to be within the Ethereum ecosystem, I think this is one of the drawbacks. This is one of the disadvantages, and as well as the advantages, because the biggest disadvantage is that it has to be a very connected ecosystem. There is no interoperability, which means that I cannot use basically Bitcoin or my traditional fiat banking system to kind of facilitate the transaction. So everything has to be within the Ethereum network. So Ethereum also has created an economic incentive, which is called ETH tokens, or you can also create your own token. Let's say Prashant coin, or let's say Fed, or let's say some Apple coin or let's say some Alibaba coin in order to facilitate the transaction. So everything has to be within the Ethereum ecosystem. But I think this is one of the biggest disadvantages also, because this way you can have a more connected and more secure world. So everything has to be within the Ethereum ecosystem. So this is the whole thing. One of the biggest advantages as well as disadvantages of Ethereum. But that's really amazing because it's also on this other side giving you the flexibility to create your own token. So maybe let's say you don't want to use Ether, right? So maybe you can create your own ERC20 token, which is a stable token, or which is an asset-backed token. So which means that you could have every $1 for every one token. So one token value you could assign at $1, you can actually back it up in some bank reserves. The best example for stable coins is USDT, is Gemini dollar. There is so many tons of stable coins coming up. There is a gold backed token. So you could basically have a stable currency in order to prevent fluctuations. Because I know for sure that everybody is going to have a doubt that Ether fluctuates. So let's say if I transact now and by the time I receive my refund or contract gets executed, the price might go up and down. But that's absolutely a valid question. But definitely you can have a stable coins to kind of remove these barriers. So on the whole, that the combination of as I told you, that the combination of a smart contract and blockchain is very, very deadly. But not only this, but I think the combination of a blockchain, the smart contracts, and the IoT and AI is actually kind of massive. I would say it's a bazooka. So basically, everybody with blockchain, so all the strangers can basically trust each other and transfer value without any third parties. And even the third parties actually cannot have access to so many things. They could just be a point of contact, or they could be just point of trust. But still, the third parties of the banks actually don't know what's going to happen, because we have seen so many frauds happening in the financial markets already. So if it's a connected world, so nobody has to basically worry about sharing anything, because everything is stored and everything is encrypted. So, this is one of the most amazing things. So I would say that a lot of new exciting applications and the platforms are possible with Ethereum, because it has computational power. It also has economic incentive, and at the whole level, it's creating an ecosystem. It's creating a trustless ecosystem, which is creating value for everyone. So Ethereum basically, as I told you, the white paper started in 2013, but the tokens and the Ether tokens was launched in 2014 through crowdfunding. So basically, they were accepting Bitcoins in terms of Ether tokens. So now we all know what Ethereum and smart contracts can basically do. Now, let's understand, how Ethereum can be basically used further. So before we, go into this, let's try to understand at a very, macro level, the Ethereum architecture, right? So just a second. Right. So, okay. So, just let me kind of, put this somewhere where you could basically see everything, right? Okay. So, at the layer also, let's say basically the apps and the D apps has basically 5 architecture layer, every application. The first is basically the consensus. So consensus are nothing but the rules of the contract, or basically the logic behind all the applications. Since it's decentralized, so you have to basically, create every smart contract. So on the Ethereum network, if you want to create your own smart contracts and publish it, there is a certain fee called a gas fee, which I was talking about. So let's say if you want to create your, own tokens or your own contract, you have to pay Ethereum network a gas fee, which is an incentive or distributed to the miners for contributing their computational power. But this is, right now is like little expensive, because your gas fee is determined by the amount of data you consume. So obviously it's very, very expensive to basically, store like GBs of data on the Ethereum network. So that's the reason Ethereum has basically kind of supported, IPFS and also Swarm network. So Swarm is basically built on Ethereum, but the IPFS is basically supported by Ethereum. So IPFS is interplanetary file system. So it's basically a peer-to-peer data storage network in the Swarm. But the only difference between the IPFS and the Swarm is basically that the IPFS is built on, IPFS is basically independent. So they basically incentivize everyone. So let's say you have a smartphone, right? So you can just contribute your smartphone's data, or let's say you have just 10 GB available on the smartphone, right? And you want to lease it out and you want to make some money, right? So you can basically lease your smartphone's kind of data or your space to the network just by connecting to the internet. So it's like a decentralized cloud storage, and you can make money. It's like amazing, right? So you imagine that we have so much of devices all around the globe and just goes waste. What if you can just contribute and you can make some money? It will basically make the entire storage system much cheaper plus secure, and also it will make everyone to earn money. So the world doesn't need to trust Amazon or Alibaba, things like that. Whereas the Swarm is basically, built on Ethereum network. So here's basically, they have answered this question. So they have basically, have answered in FAQ. So we'll look into it later. So let's understand the architecture first. So the consensus layer is basically the level O, where you have basically, the consensus and also the storage system. So how it's going to work in terms of IPFS is that. So that they have also proposed this also called an off-chain solution or a lightning network in Bitcoin to scale it up. So what's going to happen is that you're going to store all your data in IPFS or in decentralized peer-to-peer storage system or Swarm. And then a hash will be created, which will be basically pushed to the Ethereum network. So Ethereum network is going to just store the hash of a particular contract or a hash of a consensus. So just basically to make sure that this is what everybody agreed upon, this timestamp, it is immutable. And also your data which is stored in the Swarm or IPFS network is basically also encrypted, which means only the parties have access to that. But the agreed contract or the final contract, is the hash is pushed onto the Ethereum network. So this will basically, make the transactions much, much cheaper. And the new fork is also, proposes to make the gas fees, 10 times less. So you're going to understand more about the fork and how it's going to make the transactions fee 10 times cheaper. But for now, this is how the architecture works at the layer 0. And then on the layer 1, right, Ethereum also has economic architecture. So basically an economic incentive for people to support their distribution computation power. So that could be the Ether token, or it could be your own token. So it could be a stable coin as I mentioned above. So they also have this economic layer where basically one could create their own coins based upon their business model. So it gives you the flexibility to not only create your own contracts, but also your own economic incentive mechanism, which will encourage everyone to use. And then on the top of both of them, so basically you have all the smart contracts, you have reputation management, you have all the messaging services and things like that. So as I told you about the off-chain things would be basically the file system, which is basically, I just mentioned you about the IPFS or the database storage system or a Swarm. And a smart contract. So smart contract would be basically the logics for each and every transactions or for each and everything which you want to be executed on your app. And then they want to also solve the problem of interoperability in the long term. So this layers are basically, they have decided based on their Ethereum improvement plan proposal, which is called EIP. So they're slowly moving towards this. So we're going to discuss more about the EIPs and in the fork. When I'm going to talk about the fork. So interoperability is basically that, they want to basically make sure that the Ethereum blockchain could also be connected with the Bitcoin blockchain, with the Ripple blockchain, with the Stellar blockchain, or with some Hyperledger and with all the other blockchains in order to make sure that, because everybody is going to use different blockchains. So let's say if you love Waves and Waves suits your use case, you're going to use a blockchain called Wave. And let's say since you are a payments company, you're going to use a platform like Ripple or a Stellar, right? And if you are just a private blockchain application, you're going to use like a Hyperledger. But how are you going to make sure that the Ethereum blockchain, so if let's say my ecosystem is on the Ethereum blockchain and your ecosystem is basically on the Hyperledger, how are you going to make sure that you connect it in a secure way? So basically they're going to go through the interoperability, atomic transactions, atomic swap, and all the cross-chain functionalities as the blockchain matures. In fact, a lot of blockchains are just focusing on solving this problem of interoperability. And I think this is one of the most interesting things because it's going to connect the entire ecosystem together. So I think we'll be slowly there. And then on the top of that is basically the UI side or the browsers like your Internet Explorer or Internet Explorer is, I'm so sorry, it's like a shittiest browser. But I'm talking about Safari, or I'm talking about Google Chrome, or I'm talking about Opera. So in a decentralized world, you already have a decentralized browser. It doesn't basically store your cookies and your data. It's basically everything is stored within your own hard drive. So it's not stored on the internet. So you already have browsers or decentralized browser like, DuckDuckGo. You already have a browser like Brave, you already have Tor. So these browsers are gonna basically, facilitate. Browsers are like the front end between the user and the platform operator. So that back you have all these layers already running. And the top of these browsers, which is the internet, you have the, all the Dapps application, like you have messaging, you have e-commerce, you have exchanges, you have so on and so forth. So this is the architecture, basically behind the Ethereum. I'm so sorry for, saying that about Microsoft, like, so sorry, just a personal opinion. If you feel to use any browsers, you can just use it. This is all the opinions shared here. This disclaimer, right? It's just a personal, opinion. So this is basically the architecture. And after you're done with this, you're just also gonna understand about the Ethereum enterprise architecture stack. So basically, the Microsoft has partnered with Ethereum, and they have basically called the framework called the Coco framework to make sure that so Microsoft basically supports Ethereum and IBM supports the Hyperledger. So there are two enterprise blockchain solutions available from Microsoft and IBM, and I think they both are good. They are pretty much doing the wonderful job, and Microsoft and IBM are bringing both of their strengths, because both of them provide cloud services, they have the data centers, and they're trying to bring the decentralized solutions or enterprise level solutions to the clients. I think for any key application, the most important thing is the infrastructure to scale it up. And I think Ethereum is one of the decentralized peer-to-peer scalable infrastructure solution. IPF is for database, Ethereum is for application. And similarly, Microsoft or IBM is going to offer the end-to-end solution or the end-to-end infrastructure with a lot of tools into it. So once we're done with the use cases, we're going to just understand a little bit about the enterprise Ethereum architecture stack. So now let's understand what can Ethereum do, or some of the few use cases, right? So basically, as just to kind of brief up, is that we have now understood that Ethereum or a blockchain could basically eliminate all the middlemen in the network. So definitely it's a groundbreaking technology, and it's just begin, and still we have to see the impact. So basically, removing the middlemen, it would basically definitely result in a lot of disruptions, and it will change many industries, and you might see a lot of jobs and everything getting lost. So we have seen that also with the advent of the internet and the new technologies coming into picture, a lot of companies are definitely bankrupt. But the whole value and the advantages basically overweights all of the disadvantages, because it puts power back within the hands of the people, right? So the first one of the amazing examples, or the most amazing use cases, would be the peer-to-peer marketplaces. So with Ethereum, I think it's possible to create a marketplaces to have your own economic layer, your own tokens, and also to have your own consensus and your own contract altogether without you. So basically, it's like imagining removing eBay or removing Amazon, right? Because the Amazon and the eBay just acts at a layer to add trust. So one of the exciting use cases will be the peer-to-peer marketplaces. So with Ethereum, it's possible to create marketplaces where shoppers basically can directly pay sellers with no middleman required. So for example, there is an artist, selling music directly to their fans instead of using intermediaries like Apple Music or Spotify, right? So music basically could become much more cheaper, because all these platforms, since they have a business model, since they are bridging trust and connecting the end consumers with the suppliers or with the producers or with the artists, they take a commission out of it. So this commission would be, drastically reduced with the market system. So imagine that you no longer need marketplaces like eBay or Amazon. What's going to happen in that case? You have a smart contract, and the smart contract is going to say is that, let's say, if a consumer receives the goods, the payments get distributed to supplier. And now this smart contract is also connected with a shipping system, with your FedEx or someone. So the FedEx, as soon as the FedEx triggers the message that is delivered successfully, the smart contract will make sure that the money gets transferred from the end consumer or the buyer to the seller. So in this way, it will basically remove the need for Amazon. But there are a lot of other conditions which you can definitely put in place. But what I would say is that for an enterprise level architecture, you basically need a combination of a traditional, and you need to basically make sure that so this is one of the most important advice if you want to be the consultant, or if you're consultant in the blockchain space, is that you need to make sure that your architecture or your blockchain solution would basically fit within the existing infrastructure, within the existing system, without disrupting much. Because definitely enterprise would want to adopt solutions which is basically controlled to them at a lot of extent, and also it bridges the trust. So you need to make sure that a combination or a hybrid is the answer for now, because also the network is also not much scalable, and also the TPS or the transaction per second or the throughput is also really, really low. So if you want to run the entire payments network like Visa or MasterCard, definitely it's not advisable right now. So you need to use a combination of the solutions or the technology in order to make sure that you are able to get what you want. So the next amazing example could be the peer-to-peer insurance, right? So now with Ethereum, it is possible to create a smart insurance policies which could be basically automatically sold and managed like entire peer-to-peer system. Imagine that the smart car insurance that automatically charges you a small amount only for the miles you actually drive. Insurance would become much more cheaper and customized. So imagine, right, that there's a commercial vehicle, and let's say there are two people, right? Let's say there's a person, who just drives maybe car like 1,000 miles in a whole year. And there's a person who drives 5,000 miles in a whole year. So obviously, for the insurance companies, the person who drives the more car has higher chances of accident compared to the person who drives the less car. So which means that the insurance should be, the premium of insurance to the person who drives 5,000 miles a year should be more than the person who just drives 1,000 miles a year. So, it will basically make the insurance cheaper and customizable. So you can basically connect your speedometer or your tracking meter using an internet to the Ethereum smart contract. So you basically can pay the miles you drive, right? So it's going to basically make the solution much more cheaper for the person, and also it would be fair, and most important, it will also mitigate a lot of risk from the insurance company. So overall, it is creating the wonderful and the perfect use cases for everyone in the whole network, right? So insurance companies winning because they know which cars are prone to more accident. The consumers are winning because they have to pay with what they consume. So this is the most amazing thing, and this is absolutely on the real time. So similarly, Ethereum can, the most important thing is the power grid solution, or basically, electricity. So with Ethereum now, it's possible for solar panels to automatically buy and sell energy to the electricity grid. The system can intelligently sell surplus energy during peak usage hours to guest the highest prices. In winter, the system can buy extra energy as needed. So how is that Ethereum smart contracts can automatically buy and sell solar energy between users on a shared network in a city by letting people work together directly and automatically. So let's say if you have a solar house, and let's say you're going off on a vacation, right? So Elon Musk is like a revolutionary, and hats off to his vision of solar city, which means that every house or every city could have a renewable source of energy. So let's say if your house and you're going for a vacation of 2 months and there's no one in your house, and your house is going to generate electricity, and it can just store a limited amount of energy. It's going to go waste. So what if you can just share your extra energy to an entire community around you, and you could make some quick money, right? Isn't it amazing? It doesn't create a sharing economy. Isn't it creating a win-win situation for everyone? So this is one of the wonderful use cases, and I think there are a couple of tokens like Solar Coin and a lot of other social impact projects, which is kind of making sure that you could basically distribute your extra energy. So this way everybody can earn, and you don't need to have a middleman like electricity board or everyone to basically, do this. And you won't believe in India, electricity theft is like one of the biggest theft. So this could basically, prevent this, and also I could basically lease out my extra energy to my next neighbor without just getting the resources waste. So basically it is creating efficiency in the whole society. So I think combining the idea of a solar city with smart contracts is going to be like the amazing idea. And I think Elon Musk must be definitely working, and he believes the blockchain and Bitcoin too, right? So now the example fourth is definitely the personal health. So basically with Ethereum, it's possible to create a health tracking platform that monitors and rewards health related actions through connected smart device like a Fitbit or Apple Watch. So this is a use case where you're combining the IoT with the blockchain, right? For example, communities of people can come together and create smart contracts that reward those who reach their exercise goals, right? So imagine Ethereum smart contracts that are created by a community of users who support each other. Reward could automatically be issued from a pool of money when milestones are reached. For example, cities could create prize pool to incentivize a healthier population. Let's say you're friends and you have a small bet, like, the one who achieves the faster milestone or does more exercise gets rewarded. So this could basically facilitate to that. On the top of that, the biggest use case with a blockchain could facilitate, or maybe even Ethereum could facilitate, is basically storing and recording the personal patient's data. So as you go from hospitals to hospitals, right? Let's say you are already getting yourself treated as a hospital A, and you're moving with your job or something, and you want to get yourself treated hospital B. So it's very difficult for you to kind of carry the reports or the data by hospital A to hospital B, because hospital A is that one of the biggest problems is that hospital A might not use the same equipment, and also the time period has changed. So hospital would recommend you to kind of take all the tests again, because they cannot see the clarity in the reports because the machine or the equipment used by the hospital is different, and so on and so forth. But what if you're, and also these hospitals, like personally, actually they do sell your data, right? A lot of people, because your health data is, I think, one of the most valuable data, and they make a huge money out of it. So what if your patient's record or even your prescriptions are recorded in the blockchain? When you go to a hospital B, there's an app or a portal where a patient could just, the hospital could just type your identification number or your KYC and your name, and you just get a notification that, okay, hospital B wants to access your data, and you can just give the approval to them. And all your data from all your records from hospital A to hospital Z and all your past entire health analysis is shared with the hospital B in real time. Isn't it be amazing, right? It would reduce a lot of, expenditure with a person office, and also it would give a hospital B an in-depth analysis of all your past record history. Not only that, you could basically also, it could be used in supply chain management. So Snapper, as we are like a blockchain company, so we also have one of the very interesting. So we are focusing a lot, and I think we're betting a lot on the supply chain management solution. So we have created an in-house solution where basically one could basically track and trace the counterfeit medicines from the point to the manufacturer to the point it reaches the end consumer. So we have this, supply chain management solutions. Not only this, you won't believe, across the globe there is millions of deaths which occurs because of counterfeit drugs, and more than 1/3 of the drugs which is kind of stored and consumed are like kind of fake. So we have basically created an in-house solution which connects the IoT and the entire supply chain together to make sure that which is the fake drugs and how it enters into the supply chain. Not only that, but this could also be used for your luxury products like your watches, your clothes, your fashion stuff, and things like that. So we have Snapper is like your blockchain company, and we're creating a complete solution on how a supply chain could be basically integrated with the blockchain using technologies like IoT. And also the big companies would also have the backend analytics engine, which would basically help them to identify the consumer taste, the preferences where they have much demand in real time, which would basically help them to make intelligent calls, at the same time protecting the privacy of the users. So, this is the, kind of the whole, amazing idea. I think I have to just, connect my charger to the system. So just hold on for a second. Right. So yeah, so I'm back. So basically, it would basically help to kind of verify and authenticate your position product, like a kind of a track and trace solution. Also, the enterprise to get an idea and to get in-depth analytics of what they need to do. So it will help the entire ecosystem to take intelligent business decisions, and also for consumers to make sure that whatever they consume, they get the most value for whatever they are paying. And also, it could help to remove a lot of frauds from the system, like so. It's basically one of the most interesting use cases, and that's what we are also kind of pursuing that use case in Snapper. So let's kind of get back to the Ethereum explanation, right? So basically, on the whole, it's creating the sharing economy at the whole, as I mentioned to you about that, everyone can contribute, can computational power, can earn money. So you can basically earn money by contributing your data or sharing your data. So on the whole, it's creating an economy of trust, economy where there's a value created at every single actions for every single data. And I think this is one of the most amazing innovations which we could basically have seen since the internet age, right? So I think in the internet age or in our current age, the data is everything, and using your data is creating a sharing economy. So I think it's one of the most amazing revolutions. So basically, a lot of developers around the globe are people are using creating thousands of the apps are already in the pipeline and the progress, and we're going to see a bunch of new amazing applications in the in the near future. And I think that, so basically you might think that they might be a competitor to Ethereum, and Ethereum has limitations, but I think the revolution of blockchains is big. So when the internet was first invented, right, it also took internet like around 20 years for internet to kind of develop. But I think the blockchain is going to develop much faster and rapidly compared. And I think next 5 years, blockchain is going to be the mainstream. It's going to be highly scalable, and all the issues will be solved. The key for any solution to scale, or for any internet solution is to scale, is basically the infrastructure. So the one which has the huge community of developers, the software, and also the hardware, the infrastructure, gonna win. And I think Ethereum is one of the platforms of the network which basically has this huge infrastructure. So I think so definitely Ethereum. So if you have any doubts related to the Ethereum platform, you could also kind of go through this ethtalks.org, which has all the frequently asked questions. I'm going to also share the link of this, so you can just go through, and they have basically answered the questions very wonderfully. So, and also, as I told you about that, one of the biggest doubts would be that, storing files on the Ethereum is very expensive. So they have answered exactly the same way, which I just mentioned. Just have a, relook at that. So in general, you do not want to store large files or pieces of data in Ethereum blockchain because of the high cost of storage. You will need to use a third-party storage solution such as Swarm or IPFS. Swarm is an Ethereum-specific project for distributed storage file system. IPFS is a non-Ethereum project which has close ties to Ethereum. So it will be used independently and maybe used as an added layer underlying Swarm in the future. So you can see the Stack Exchange post for more information. So if you have any other doubts or queries, Ethereum also has a huge network. So you can huge network of it has a huge network of community. So you can go to the Stack, you can go to the Reddit, you can go to Telegram and post your questions. And I think the community is super active, and they'll be happy to answer all your queries related to Ethereum. So this is one of the most interesting FAQs, like what's the future of Ethereum? So Ethereum, so as I mentioned that Ethereum developers are planning to switch from proof of work consensus to proof of stake consensus model in the future. They are also investing in a lot of other scalability solutions, how to store secrets on the blockchain. So they have basically decided to move to proof of stake, and that's how the new hard fork, Constantinople hard fork, is kind of taking a step closer for this transition. And let's now try to understand what is this proof of stake in detail. And even if you want to kind of learn more about Ethereum, our YouTube friend Siraj has also explained like really well. I'm also going to share the link to his video if you want to kind of just understand more from him, or basics. So he has covered the basics really well, all the layers and everything, thanks to Siraj for his great work. So now let's try to understand the proof of stake. So basically they have okay, so basically Vitalik has written a very interesting article on the Ethereum blockchain about proof of stake. We're going to go through that, but let's try to understand what is proof of stake first. I think it's one of the most important. So basically the lad Zamfi, so he's one of the most recognized developers in the Ethereum network. So they have basically called this entire upgrade as the Casper upgrade, or the Ethereum Casper, which also means the friendly host. So here's a brief about why they have wanted to basically move to, proof of stake is basically, as I told you, to increase the scale, to make the solution more scalable, to make the transactions much more cheaper, and also to, and also to ensure the security of the network at the same time, and to also to increase the transactions per second, right? So basically, the proof of stake one, it has security based, it has security deposit based authentication mechanism. So basically, as I mentioned, as the word staking, so the word staking means is basically that you have to basically stake Ethereum in order to become a validator, or in order to basically authenticate the block. So basically you have to kind of stake your Ethereum. So it's going to be kind of a bidding system on the whole. So let's say if you have 100 ether to validate one particular block, and I bet 200 ether to validate the same block. So basically the one who has bet more is going to win, because he's more confident about mining the block, right? But at the same time, it is also like, because that I have bet more, because also it also gives the assurance to the network that definitely I have the bigger or the higher infrastructure. So it's all gets basically locked. So Ethereum Foundation doesn't have control on your staking. It's basically it's locked in an Ethereum blockchain itself. So as they mentioned that basically So Casper is a security deposit-based economic consensus model. This means that the nodes, so-called validators, have to place a security deposit, and actually we call it bonding, in order to serve the consensus by producing blocks. So the protocol's direct control of these security deposits is the primary way the Casper affects the incentives of validators. So specifically, if a validator produces anything that Casper considers invalid, the deposits are forfeited, along with the privilege of participating in the consensus process. The use of security deposit addresses the nothing at stake problem, that behaving badly is not expensive. So let's say if you don't have anything at stake, so currently right now in the proof of work, you just have the network of the miners, and you can just basically put your mining rigs or your mining rigs, right? So it's based on proof of work. So you just have a mining rig, you don't have anything at stake. So there could be a chances of 51% attack recently, which we have seen with Ethereum Classic. So the network would basically want to, do some fraud things, or want to become a bad, or a person who controls the majority of the network want to become bad, and he has nothing to lose, just nothing to lose, because he cannot be banned from the network, right? So there are chances of people doing, 51% attack, also 51% attack also in the near future. So basically this would address the problem of nothing at stake. So since you are staking, right, and you won't want all your Ethereum to basically get lost or get basically gone if you do something fake. So how the network is going to determine whether whatever actions you performed is right or wrong is, again, they have a voting process, they have a consensus towards it. So what's that? Just understand future. So very notably, validator signature is only economically meaningful so as long as the validator currently has a deposit. This means that the client can only rely on signatures from validators that they know are currently bonded. So when you stake, you basically get bonded. It's like you put money on one company, you put all your heart and soul into that one company, because you have your money there, right? So therefore, when clients receive and authenticate the state of the consensus, their authentication chain ends in the list of currently bonded validators, right? So your chain would end with the bonded validator once they kind of approves it and verify it, and also the one who stakes more, because the guy who stakes more is confident, because A, he doesn't want to lose their money by doing something fraud. Two, he also has the higher or a faster computer infrastructure or a network to kind of validate the blocks faster. So, if you, so in proof of work consensus, on the other hand, authentication chain ends in the Genesis block. As long as you know the Genesis block, you can authenticate the consensus. So basically, as I told you, in the proof of work, I have nothing at stake. So basically, let's say there are the pools and things, and I could basically combine the infrastructure to do a 51% attack, and I have got nothing to lose. So, but also at the same time, this will also result in the change of a power, or a change of the validators list moving from one person to another, because the one who puts more bets will basically kind of will have the higher reward. So basically also it will kind of ensure the security to the network. So therefore, if clients are offline for too long, their validator list will no longer be current enough to authenticate the consensus. In the case that they're online sufficiently often to observe the validator set rotating. However, clients are able to securely update their validators list. Even in this case, clients must begin with an up-to-date list of currently bonded validators, and therefore they must authenticate this list out of band at least once. So let's say if you want to create your DApp or something like that, it will also give you the option to kind of select your own validators or your own transaction validators, or the people who you can, trust. So, or the miners whom you can trust. So this is basically driven by feedback, kind of a system. So and also on the whole, what's going to happen is that they also have a voting process on every block. So ones who basically stakes more will become a validator, right? And but the block to verify it. So there'll be a lot of other people who are going to be bet on the same blocks. So the one who's going to betting on the same blocks is going to go by a probability, right? So let's say if everybody's betting on the same block, right? And then, all their funds are locked, one. And then what's going to happen is that they're going to be the voting process in order to verify. So they have to also verify whether whatever the results I have produced or whether whatever the blocks I have added is the correct blocks or not. I might do some fraud. I might try to, kind of modify the data in that particular box. So they have to basically track it. So again, this is going to be the voting process. So everyone who has stake and the network will basically vote on the decision made by a validator. So if let's say there are 100 miners, and let's say if 100% agree to what the validator has validated the block, which means it's true. Even if one disagrees, then it's going to go to the network to re-verify it, because there are chances that if one has disagreed, there are two scenarios. Scenario A is that the guy who disagrees wants to do some kind of fraud, or a scenario B that all the 99% of people have come together to perform a fraud or to perform a network hack. That's the reason even one has, disagreed or one has, not voted. So they're also going to follow the probability voting system per block to determine whether the validators have performed this task correctly or not. And basically this is like gambling on consensus, right? Because you're basically putting money, you're staking your money. So definitely don't want to, use it. So it's kind of a good gamble on the whole. And the people who are a bad intention will basically use it because to re-verify it, they also have a voting process. After they appoint the validators. So basically this is, how the thing's going to move, and this is what by height consensus. So this also connects or brings to by height consensus, because the validator is going to bet independently at every block number by assigning it a probability and publishing it as a bet. So though iterative betting, the validators elect exactly one block at every height, and this process determines the order in which the transactions are executed. Notably, if a validator ever places a bet with probabilities summing to more than 100% at a time for a given height, or if it's less than 0%, the bet with more than 0% on an involving block, then the Casper forfeits their security deposit. As I told you about that, you have to deposit every stake. So as I mentioned in an example, that if any of them kind of vote against it, so the network is going to re-verify or recheck it, and automatically in the process of re-verification, find out that someone has done a fraud, they're going to block it. They're going to take their money and also they're going to block it. So in this way, and the staking system definitely want to do something bad. So basically, it's just put in this, try to understand a simple way, right? So if you put your money in one particular company, or if you invest in a particular company, it doesn't want that company to go lost. So you're going to make sure with your own most honesty, most integrity, you're going to make sure that the company particular succeeds. So this is the whole, idea behind this. So this would basically, lead to the transaction finality. So when every member of a super majority of bonded validators, so super majority validator are basically a set of validators who meets a protocol defined threshold, somewhere, 67%, 90% of the bonds. So they basically, the bonds are like the bonded validators who are like, most active in the game. They are continuously placing the bets, are the people who called, basically are called, bonded validators who bets on a block with a very high, let's say more than 99% of the probabilities. Let's say 100 blocks get produced and I bet on more than 100 blocks, which means I'm a super bonded validator because I'm staking at every single time, right, on a block with every say. So basically, these are the guys who are going to have a super validator, and the fork choice will never, so bets on a block with a very high say, like more than 99% of the time. So the fork choice rule never accepts a fork where this block does not win. And we say that the block is final. Additionally, when a client sees that every block lower than some height h is final, then the client will never choose a fork that has a different state of height, let's say h minus 1, than the one that results from the execution transaction that finalized block. So let's say you are a client and you want to basically, in the whole you are a miner, right? And let's say, so this is basically, they are given some scenarios where the network is going to identify. So let's say there are a lot of blocks. So let's say there is a block of height X, and based on, analysis, the most of the blocks are in the range of X. And there's some unusual activity happening, right? They could just immediately track it. Let's say the block height is something like H minus 1 or X minus 1. The network stand immediately will track it and going to again go through a voting process to identify whether that block is valid or not. And let's say they can also identify in this process whether who's the validator of this block and how's the voting process followed. So basically, this would result to censorship resistance, meaning in currency proof of work, once the block is produced, you cannot basically alter the modified. You have to produce a new block altogether. So basically, which would lead to certain disadvantages. But here, what's happening is that they can basically go and re-verify the block, and they can basically change the status of a block if there is some invalid transactions happening in a block. So basically, that's whole the censorship resistance is, right? So now the most important question is that will there be more transactions per second? Absolutely yes, because people's gonna. So let's see the answer. So basically, absolutely yes, because the economics of the Casper, rather than due to its blockchain architecture. However, Casper's blockchain does allow for faster block times than is possible with proof of work consensus. So validators will likely be only earning the transaction fee, so they have a direct incentive to increase the gas limit, correct? If their validation server can handle the load, however, the validators also have reduced returns from causing other slower validators to fall out of sync. So what's going to happen is that people are going to invest more and more into the infrastructure. So validators need to have their own infrastructure. So if your infrastructure is less or is not compatible with the upgrade, you just fall out of sync, which means is no longer valid. But currently what's happening in proof of work is that even my old machines I can use to kind of mine. So this is a little controversial because so basically it's going to require more and more investment just to become a validator, just to keep on investing into your infrastructure. So this is kind of a controversial because all your old systems or your old investments on your infrastructure is going to go out of sync. But definitely, yes, they say there might be going to be more transactions per second, because the more the persons take, they're going to get more the mining fees. So basically, if you have the bigger or the higher or the better infrastructure, you can earn more out of it. So it's like basically your typical business where you have to keep on reinvesting your earning to get more. So that's how you're gonna. So basically, the miners wanna invest more and more into the infrastructure because they want to be always ahead of the game. They want to be always get more, incentivized. They want to get more money out of it. So this is the whole, idea behind it. So they have also talked about that, recovery from net splits. So basically, Casper is able to recover from network partitions because transactions non-finalized blocks can be reverted. So as I told you about, net splits kind of a problem where you cannot alter the data into one of a block. And also it's also related to fork. So we're going to talk about next is basically the hard fork and the soft fork, and also the Constantinople fork, right? So after the partition reconnects, Casper executes transactions of the blocks that receive bets on the partition with the higher validator participation. In this manner, nodes from either side of the partition agree on the state of consensus after reconnection and before the validators are able to replace their bets. So validator bets converge to finalize the blocks in the partition that had more validator participation with very high probability. So Casper will likely process the losing transactions from losing blocks after the ones from winning blocks, although it is still to be decided whether validators will have to include this transaction in new block or if Casper will execute it in the original order itself. So a lot of time what happens in the blockchain is that your blocks, you basically get stuck. Miners won't validate it or won't process because the incentive on that particular block is like really less. But some wants to verify the block, because so let's say if you're staking on one block and you see one block where no one has staked and it's kind of stuck here, someone who has a very little stake will take this, try to become a validator because they basically could incentivize it. So the people so currently in the proof of work, what happens is that the miners don't want to process the block which rewards them, which basically has the very low incentive or the very low mining fees. They would want to go for a block, or they would give more priority to the blocks with higher incentive. That's why we see that sometimes the transactions on Bitcoins or even on Ethereum takes little time, or for your wallets to get credited, because the miners don't want to mine the block which has low transaction fee. So what's going to happen in the stake is that everyone is going to look out for basically, which blocks to stake, because the blocks going to get produced every second, like very fast. So you're going to go through blocks which has less stakes, and where the miners has basically it shoots their pockets, I would say. In other words, so let's say if I have just 100 ETH, so I'm going to go for a block which has just a 90 ETH as a deposit or become a validator, because I could become a validator of that block. So basically, it would help the network to stay more stable, because even the small miners with small, Ethereum, they have to stake. They're going to look out for blocks, which other miners or other validators are not validating it. So that's how it's going to help it from, net splits problem. And definitely, this would also help the network from mass crash failure, right? Because Casper is able to recover from the crash. So what is the mass crash, right? So mass crash is something like 51% attack, because here there's no, so they don't have to worry about a 51% attack one, and also since it's based on staking, everybody wants to put more and more money or more and more skin into the game. So they're going to continuously upgrade the servers, and even if everybody will remove out, so the one with who is there into the game will win, because the reward will go to him, all the rewards will go to him. So they is basically in the staking system, what's going to happen is that the more the skill you put into the game, the higher you're going to win. So this is the whole concept, in a nutshell, for the proof of stake model. So bonded validators can always produce and place bets on blocks on their own, although they always make higher returns by coordinating on the production of a block with a larger set of validators. In any case, a validator makes higher returns from producing blocks that not from producing blocks. So obviously, right, if you have less to stake, as I mentioned about, at least you can earn something out of it. So it's always better to earn something than earning nothing. So additionally, bonded validators who appear to be offline or too long will be unbonded, correct? And new bonders subsequently to award join the validation list. So Casper can thereby potentially recover precisely the security guarantees it had before the mass crash failure. So everybody's going to look out for the bond. They're going to continuously put more and more computation power, more and more stakes in order to become and to get into the validator list. So what it is like to be bonded validator, right? So as a bonded validator, the biggest advantage is that you need to basically securely sign blocks and place bets on the consensus process. If you have a very large deposit, you'll probably have a handful of servers in a custom multi-signature arrangement for validation. To minimize the chance of server misbehaving or being hacked, this will require simple experimentation and technical expertise. The validator should be kept online as lightly and as much possible for it to maximize its profitability, or for otherwise it is unprofitable. It is very advisable to buy DDoS protection. So one of the biggest disadvantages being a stater or validator is that since the validator lists are known, there could be a chance that the other competitors could kind of have a brute force attack on your servers. Basically, a brute force attack is an attack which your server can't handle, and it's beyond, as it terms it, it's like massive. It's like a lot of bots, a lot of viruses, managers to attack. So a lot of times what going to do, your competitor is going to do there is that since the validator list are known. This is one of the disadvantages I would say of a proof of staking system, is that if a network knows who are your validator, like your opponents or your enemies could basically combine together in order to attack you and bring you down. So that's why they have suggested to buy a DDoS attack protection. So kind something like a Cloudflare or some other services, which would basically help you in identifying the brute force attack and prevent it, because here the validators list are known. So in the proof of work, you just know the hash or the IP. You don't know who the validator is and from where is it coming, since it's 100% decentralized. But here, one of the biggest disadvantages is that since the validator list are known, so small group of people or basically can combine together to do a brute force attack. So this thing of a big way, right? You have a vast kingdom, and to bring you down, like there are smaller kingdoms who would combine together to, so they have a larger army against yours to bring you down. So this is like, what it's like. So one of the biggest disadvantages of being a bonded validator or in the proof of stake system is kind of a brute force attack, which is, which all your enemies would kind of do in order to bring you down. So what is like to be an end application, developer or a user, right? So applications and the businesses benefit a lot from the change from proof of work consensus to Casper, because there'll be low latency, the transaction fees or the gas charges will be reduced significantly. In normal conditions, the transaction will be finalized like very quickly, almost real time. And in the event of network partitions like forks, on the other hand, transactions are still executed, because when there's a fork happening, so what's happening in the fork is that typically a lot of times we see exchanges suggest not to do any transactions because the network is transitioning or the network is upgrading, and the chances are you might still lose your money. But in the fork and on the staking model, what's going to happen is that some might still going to place bet, because the bigger ones going to kind of, if you're in transition process, which means you're not earning any rewards. So the smaller validators or the smaller bonders would kind of still place your bet in order to make sure that still get incentives from whatever is available, in the cake or in the whole game. So this way it's going to basically also make the network to make sure that, the transactions can also be processed in terms of fork or when there's a change happening. So the application developer therefore still needs to deal with the possibility of forking as they do in proof of work, but the consensus protocol itself provides them with a clear measure of what it should take or for given any transactions to be reverted. Because as I told you about that, in current blockchain proof of work, on transactions, then it cannot be kind of reverted. It cannot be reverted back. The blocks cannot be modified. But here, since based on the consensus, they identify that the block has to be kind of there's some wrong data into the block or something, they can just go back and kind of change the block. So in a traditional proof of work blockchain, they have to go from a genesis block. So I told you about the genesis block is a block 0, the first block. Since all the blocks are connected from all the roots, so this is what a Merkle tree or a Merkle root is like, because it's all connected all together. So in a proof of work, if they have to modify anything, they have to go to the roots in order to modify it. But and that's going to take a huge computational power, because you have to modify not only the genesis block, but based on that, you have to modify all the blocks which is connected, because they're linked with each other. In proof of stake, you can just go to that one particular block and just modify it, then modifying the entire block. So you can basically, I'm going to also put a link to this post, and you can kind of also understand more about it. So I think Medium is one of the most amazing things which you can follow, and you can also follow Ethereum there, right? So basically, for developers, if you're a developers and if you're a coders, Ethereum offers most amazing, basically kind of solutions how you can basically create your own cryptocurrency. So basically the Ethereum has a lot of use cases and repositories where you could basically use the codes and learn how to code. So one of the basic things you have given is like the creator creator, the digital pal who's fun to be with, right? Like a bot. So how you can build a smart contracts, using the Ethereum Solidity. So they have given the codes, the logics, they have explained it really well. And the Remix is one of the platforms for basically using or coding your Solidity. It's basically, the platform, right? So they have given the in detail. So I'm going to also, if you're also a coder, I'm going to also attach the links to few of these. So you can basically go back and, you can also learn how to code. So this is also one of the most Ethereum builders like Gitbook, which gives in-depth example of all the Solidity and, the codes, and it's very simple, and it's also very interesting. So you could basically learn how to code, and you can also become an expert in coding, and you can also build some amazing apps. So they have the entire index and how to connect the API, the Java. So basically, Ethereum or the Solidity is based on mean stack, Node, Angular, and React. So mean stack is one of the most amazing technologies. And I think if you're a developer, you have to focus on mean stack because it's much more dynamic, much more secure. And I think most of the technologies are, kind of based on mean stack now. So there is also Block Geeks, which is basically explain how to learn Solidity. So they have, mentioned about for developers, for businesses, if you're an investor or startups, or if you want to learn and understand how to, basically code and what to see if you're evaluating a smart contract. So there are a lot of, so internet is like an amazing ocean of knowledge. And then there's also a lot of other GitHubs you can go through. You can follow a lot of community around Slack, Telegram, and Reddit if you're looking forward to learn more about the coding and more. So you can basically Google. So I'm going to put links to some of the things which I find interesting. So the Tron blockchain. Tron is basically the blockchain for content management. They have basically posted an interesting guide what is basically kind of a difference between a proof of work and proof of stake, and also delegated proof of stake. So the Tron and EOS is basically based on a delegated proof of stake. So we already learned about what proof of work is. So where the computers in the network minus work to solve a cryptographic puzzle repetitively. So they are performing one task repetitively, consisting of the fundamental hash. Like take Bitcoin as an example, the first computer and network of computer, that is a mining pool that found a hash with specific properties, rewarded few Bitcoins with every 10 minutes. This is a proof that they have done the necessary work to verify all transactions in a block as validate and is allowed to add to the blockchain. Committing a fraudulent transactions on the blockchain require the party to have half of their total hash rate in the entire network, which is a 51% attack. which I spoke about recently. So since this process requires immense amount of energy and computational usage, it's extremely hard for someone to basically do a 51% attack. So you won't do a 51% attack because you need a lot of computational power, a lot of energy input. Basically, you gonna end up, or the mine is gonna end up burning a lot of energy. So this is one of the biggest Bitcoin pools, Bitcoin mining pools. So BTC.com is the largest, 28%, and you have AND pool and via BTC. So these all are the pools, or the mining pools, which is basically in the mine, basically on mining. So since proof of work is regarded, it's very energy inefficient, not environmentally friendly, and it has also a lot of disadvantages which make Bitcoin isn't decentralized as it should be. But newer cryptocurrencies are moving away from proof of work consensus mechanism. So basically they are moving to something like proof of work or delegated proof of stake or a lightning network. But there has been recently a very interesting conversation on Twitter. If you follow Charlie Lee, one and only the founder of Litecoin, he says if a network is, so there was a debate recently. So if a network is not prone to 51% attack, which means it's not decentralized. So it is actually right in a lot of ways, right? Because if there is no chance of 51% attack, which means the network is not decentralized, centralized. So because if you say something is decentralized, they have to be a majority to kind of identify. So let's say there are 100 people, right, and 51 people say yes, which means it's decentralized. But if let's say one person in a company holds 51% of the share, it's one person saying and not the best 99% persons, which means that this is central authority because it controls everything. So there's one interesting conversation which is 100% decentralized, is not centralized. But I think the major focus should be more being decentralized and at the same time also be scalable, right? So they decided to have a proof of stake. So basically, as we discussed that in proof of stake, it doesn't require the computers to perform repetitive computations, thus being more environmentally friendly. So proof of stake replaces miners with validators, where they will lock up some of the coins as stake or deposit. So as I told, so a group of validators take turns proposing and voting on the next block, and the weight of each validator's vote depend on the size of its stake. So the more it's like a gambling. So the more you stake, the better chance of becoming you the validator. So when the validators discover a block which they think can be added to the blockchain, they will validate it by replacing a bet on it. So the validators get a reward proportionate to their bets. Anyone who holds the blockchain-based cryptocurrency can become a validator by sending a special type of transaction to lock up the fund. So there's a continuous process of betting, and staking. But in DPoS, so what's basically delegated proof of stake is, they say that it's more efficient than POS. But recently, even the delegated proof of stake, if you see the EOS which they have adopted, there have been a lot of controversies there. Testnet failed, it backfired, there's been so much going on. So actually these things, proof of stake or a delegated proof of stake, hasn't been fully tested yet. But proof of work has been in existence since 2009, since Bitcoin, since 2010, since the Bitcoin, and we have seen that actually working. So this is still at a concept, but a lot of believe that it's going to work. But on the delegated proof of stake, which is use a reputational system and real-time voting to achieve consensus. So community members, so it's going to work for super representatives. So super representatives are like the head in the entire thing. So they're going to vote them. So I elect the super representative who's going to basically vote or identify the one head, like say a president or a prime minister. So all the citizens going to elect the prime minister based on his reputation and the one who's going to basically be the validator, right? So this is how they're going to. So basically what they say is that in super representative thing, the one is, since it's based on a reputational score, nobody would basically want to do a fraud, because everybody has a voting right irrespective of number of stake or the amount of stake they contribute. So my vote, so I have 1:1 vote, which is irrespective of if I commit 100 Ethereum or I commit 10 Ethereum. So I have a one vote. I have one person is equal to one vote. It's a simple democratic system they're going to follow to elect the super representative who's going to basically become the biggest validator. So basically in Tron's case, they're going to be like 27 super representative, and they have some 1 billion Trons as a reward. So basically the main difference between the delegated proof of stake and proof of stake is that in delegated proof of stake consensus, community members have more governance rights in the network, because your one vote is basically one person is equal to one vote. Whereas in proof of stake, the voting power is more with the person who basically stakes more onto the network. So since the vote in the delegated proof of stake is like basically always going to elect a super representative, and if a super representative or the head doesn't behave or perform well, the community and the people can remove in real time. So their votes essentially finding the bad representative, the super representative must always try the best to obey all rules and keep the network uptime as possible. Otherwise, the super representative will be overthrown by the community members. So Tron, which is an amazing blockchain that's seen a lot of traction recently, and we're going to talk about Tron as well in our Snapper blockchain series. That Tron chose DPoS as its consensus mechanism. It's more decentralized protocol, the democratic, self-governing, community-free elections, and overarching legitimacy. But still, this also had a lot of controversies. Because what if all your validators are just belongs to Tron, or all the voting person belongs to So it's like basically, let's say there are 100 people to vote in a network, and you just buy 60 of them, or you just buy 51% of them belongs to you, right? They're gonna elect how you're gonna do it. So this is what one of the also the disadvantages, logically speaking, in DPoS. But still, we have to see how it works. And I think it backfired in the EOS. The data network got backfired. So I think still they have to test and we have to see what's going to work. But I think we have seen the success of proof of work already so far. So I think that's for now. And also this is a detailed thing. What is proof of stake? So Max Thake has also explained amazingly, taking the definition out and how it works. So I'm going to also attach the links to these. So if you want to have a look at it and understand more about proof of stake, you can add it. Now, just understanding the enterprise Ethereum architecture. So Microsoft announces the release of project Blacksheet version 1, a modular blockchain fabric which is powered by Azure. So Microsoft, as I mentioned, has partnered with Ethereum and have launched a Coco framework to kind of support the blockchain. So this is, they have their, their database layer, they have the middleware layer, and they have the industry solutions built on the top of that. So and they're going to basically, provide all the tools and everything required, in terms of building the right application. So one below, they have the network, which is basically enterprise peer-to-peer thing, or which is your development. So you have the legend is like, so basically they have described the yellow ones called the yellow paper, the green ones like the public Ethereum. So they have basically created a combination of, a permission blockchain, which is a kind of private blockchain, the public blockchain. So what are the services going to have, which is a public Ethereum related, and which is going to be provided by Azure. So this is a blue one stands for application, and the purple or a slight one is for basically, enterprise Ethereum stack. So they're going to have network, the core blockchain layer. So the core blockchain layer is basically a combination of both. You can see at Ethereum and enterprise. So they also have the off-chain storage. So what is the off-chain storage? So off-chain storage is kind of a scaling up. So in off-chain storage, as I talked to you about the IPFS, right? So IPFS is kind of an off-chain scaling solution, because what you're going to do is basically to push all the data into IPFS, you generate hash, and that you store it on the Ethereum blockchain. So in the off-chain solution, what's happened is that basically so you can basically run the block, which is a Ethereum blockchain, and also the side chain parallelly. So let's say there is a block A, right? And then the block A is basically comprised of block A1, block A2, block A3, and block A12, block A13, so on and so forth. So all this put together is basically block A1, but the block A is basically on the public chain, because it's just a hash, or it's just contains the finality of the transactions. But there are a lot of parallel processing related to this block A is going. But in the proof of stake, what's going to happen is that if it's basically a proof of work, right? So the network cannot move from block A to block B, because they have to complete block A totally first. But in a proof of stake and in the off-chain solution, the network can also move to block B, block C, block D, because the block A is already working on parallelly block A1, A2, A3, A4, and so on. So this is kind of an off-chain solution. So the entire network is also being dedicated with other blocks, and all once the transaction on the block A1, A2, and everything is finalized, they all put together this block A. So this is kind of a off-chain solutions. So which will basically make network more and more scalable, because you can basically process a lot of transactions at the same time, and the block could, or the blockchain could basically move forward and forward and forward, like at a faster rate. So they have the privacy solutions like a private transactions off-chain, which is a trusted again, which I explained. And then they have a lot of tools on the top of that, all of your keys, your wallets, your interchain, your oracles and stuff like that. And on top of that is like application. So you have, so in application has smart contracts, applications has tokens, token standards. So this is what their enterprise Ethereum architecture stack looks like. Down you have the network protocol. So basically you can define what kind of protocol you want to have, and then you have core blockchain solution, which is like an off-chain, on-chain solution. And then you have a privacy and a scaling. So this is more focused on, kind of interoperability and swaps to make sure that the one blockchain should be able to communicate with the other blockchain. So, and then you have the tooling, which has all the key management, your wallets. It's like basically a back end or kind of backbone, which basically connects your front end with your back end. And then you have the application layer on the top of that. So this is the enterprise Ethereum architecture. Now coming to the fork. So the fork is one of the most interesting concept for everyone. So basically there are two kinds of fork. One is basically the hard fork and the other is the soft fork. So soft fork is basically that, there's no compulsion on the network to kind of, adopt. So there is no compulsion on the miners to kind of upgrade their systems. But on the hard fork, every miner has a compulsion, the network has a compulsion to upgrade the system. And once they upgrade it, they cannot go back. So if it does not upgrade, you just get kicked out of the system. So that is the hard fork. But the Constantinople is a hard fork and it's supported by Binance, Huobi, and all the biggest exchanges, because it is more focused on the Casper. It is more focused on scaling the Ethereum network. So the community is supporting the Constantinople hard fork, and you're going to get the new tokens based on your Ethereum, like 1:1 proportionate. So basically, to achieve the Casper, to achieve the Casper, there is a big journey which the Ethereum has basically called EIP, Ethereum Improvement Protocol. So basically, how the Ethereum community works is that from Vitalik to everyone in the community, they propose their solution which has to be adopted, and then they have a voting mechanism in which they decide which improvements to kind of go for and achieve, and what are the milestones. So this is basically like a milestone for their end goal. So one of the first improvement protocol is in the Constantinople hard fork is EIP 145. So which is basically the bitwise shift instructions. So basically the new instructions is basically the whole idea is to use 10 times less gas, which means running the smart contracts will be much, much cheaper. So as I told you that you have to basically pay the Ethereum network in a gas fee or a transaction fee, which is called gas. So the gas is basically also represented as GWEI. So you have to pay gas every time whenever you use the Ethereum network. So they basically, with this, they want to basically consume this protocols, or this EIP 145 is going to consume 10 times less gas, because the whole idea is to make the transactions cheaper, which the transactions are also your smart contracts. So smart contracts are your transactions. So if the smart contracts are expensive, obviously it will basically hold back a lot of people to not to use the network, and a lot of people use a network, something like a Hyperledger or any other alternative, because there is no gas fee, because you can put unlimited transactions or unlimited smart contracts without worrying about the gas fee. So I propose to make the gas 10 times less with this EIP 145. And then you have EIP 1052. So this is basically the hash of smart contracts. So basically, this is also related to the IPFS and the swarm, which I told you about, because pushing data onto the blockchain is like really, really expensive. So let's say if you want to push 10 GB or 15 GB or 23 GB of data, it's going to consume like a lot of gas and going to cost like, maybe some hundreds of thousands of dollars. So what they want to do is that in this EIP, they want to take the hash, or they have to just take so once the transaction is finalized, or once the data is pushed and loaded, they're going to generate one hash. The hash contains basically the timestamp, the transaction detail, the size, and what is involved. So what is involved in that particular transaction. So they just want to take the hash of that from the IPFS or from the swarm and just put it onto the blockchain, which means it's going to consume less gas. It's going to be less expensive. But at the same time, this is also connected. This is also providing trust and the transparency, because anyone could just use the hash and go back and verify it again. So this is what EIP 1052 focuses on. The next is basically the state channels. So state channels, as I told you, is basically the combination of an on-chain and an off-chain solution. So as I told, or as I mentioned, it is also similar to Bitcoin's Lightning Network. So let's say in a blockchain or in a proof of work, what traditionally happens, basically they have to go step by step. The whole network is mining, block 1, they cannot basically go to block 0, or they cannot move to block 2. Only after completing block 1, they can move to block 2. But in the state channel, what's going to happen is basically that they can also process a lot of parallel transactions at the same time. So what's going to happen is that, let's say if block 1 is there, the block A has going to have block A1, A2, A3, A, because all these combine together. is basically forms block A, but the network has to move fast. They cannot basically delay the network. They have to be highly scalable. The TPS has to be more. This is basically related to 1052 because the hash of smart contracts. So let's say if block A basically contains lots of data and is connected to lot of databases or lot of IPFS from different people. But the network has to move on. They just cannot delay it because this particular block has to process 10 GB, right? So basically, this will basically, so the chain, which is an on-chain or the Ethereum chain will go on, but at the same time, the miners can also work on the off-chain solutions. So this is what the state channel is about, that basically to have or to process parallel transactions to make sure that the Ethereum network performance is not affected, and network would basically mine all the other blocks. They can move ahead. And this is ZIP 1234. This is like a very controversial one as well. So basically, they want to delay the difficulty bomb and also reduce the block reward. So currently, there is basically the network. So the miners get around 3 Ether per block for mining it, and they want to reduce it 2 blocks. So basically, they want to make sure that the incentive is reduced to 2 per block. So the whole idea is that since the Ethereum, there is no limitations on the total cap of Ethereum. There could be unlimited number of Ethereum in the network. So the whole idea is that they basically want to reduce the supply and also the inflation, and which would basically stabilize the price, right? So this is the whole idea, and they want to reduce the whole block. So there is also a thing called there's also dealing difficulty bomb. So there's a thing called in the overall Ethereum roadmap called Ice Age, where no Ethereum could be mined any further. So what happens typically Ice Age is that once the Ice Age is achieved after a certain point of time, the miners won't want to contribute the network because the mining reward is totally gone. They could just earn money out of the transaction fees. So they want to delay it. They want to delay the difficulty bomb, and they want to make sure that because they want to have more and more miners onto the network to performing and to stake. So they want to also delay the difficulty bomb and prevent the network from reaching the Ice Age, where there is no incentive for the miners basically, right? They just have only the incentive, the transaction fee. So this is what they have proposed in order to, so basically they want more investors to get in. They want more people to hold it, because the more they hold, the more they're going to stake, right? So basically the whole idea is that they want to make it viable for the investors. They want to make it viable for the developers. They want to make it viable for the whole community to hold Ethereum, to buy and to basically stake it. So this is the Constantinople hard fork. So this is going to have crazy impact on the price, because a lot of speculation is going to happen. So it's very difficult to say what's going to happen now, but it's at the kind of the hard fork is around end of January. And also one of our YouTube friends has explained in a much more amazing way about this thing. I'm going to basically put the link to the hard forks as well, and some of the videos which you could watch to kind of learn more about the hard fork, right? So I'm gonna talk more about that as well. So okay, now let's understand more about ERC20 tokens. So I think definitely we would want to know. I think it's very important for everyone to know what are the token standards in Ethereum, because token standards are one of the most important economic incentivization in the Ethereum protocol. So basically, they are basically 3 kinds of ERC right now: ERC20, ERC223, and ERC2721. So basically, we have to understand what ERC means. So ERC standards mean for basically Ethereum request for comments. So ERC is authored by the Ethereum community in the form of memorandum describing the methods, behavior, research, or innovation applicable to the working of the Ethereum ecosystem. So basically related to the incentivize or related to the economic system of the Ethereum ecosystem. So it is submitted by the entire community. They review and they decide which standards to have achieved. So basically they have finalized 3 standards of it. So one is the ERC20, which is the most common form of most common form of a token standard or an economic incentive in the Ethereum protocol. So most of the ICO, so basically it lets you create your own tokens based on your own business model. It's like basically you can have your own money, or you can have the own features of money based upon your business model. So you could have a stable money versus a volatility money based on your own business model. So this will basically give the developers and the users and the businesses to consent to basically kind of, customize the economic system I think it's like really cool, right? Basically, you can basically customize the features of your own money. You can make sure what kind of supply it should be, how the token should be burned, and how the inflation mechanism should work. So this is the most common form of token issuance, and I think most of the tokens, like more than 99%, is based on ERC-20 standards. And next you have, so basically the key benefit which we get here is that any application or smart contract can interact with her token in a standard manner without a need of knowing other details about the token. So it's like a standardized economic incentive. Therefore, we have a very pleasant way to create any ICO token and have a standard way to interact with all of them like they are all the same. For instance, crypto wallet developers can avoid custom development integrations to add new tokens. All they need to do is the Ethereum token standard that, basically which is standardized. And so this is, so I also post a link to this Medium article that beautifully explained about ERC type standards of token. The next is ERC 223. This is still in the proposal. So basically this was introduced by a developer who decided to solve issues of the ERC-20 standard for tokens, right? So basically the advantages here is that basically provides a possibility of avoiding accidentally lost tokens inside. So in the ERC-20 tokens, what basically happens, one of the biggest disadvantages is that once a transaction is done or the token is lost by, if you do some wrong coding or, if there's some bugs in your code, there are chances that, someone might basically hack or your tokens might get lost or someone can basically modify your smart contracts and someone can hack it, you cannot retrieve it back. But ERC-223 basically maps it to the genesis or maps it to the end or maps it to your basically the roots of it. So let's say if someone tries to hack or your tokens are lost, you can basically kind of retrieve it back based on your address or based on your ownership by basically defining the ownership of the smart contract, irrespective of who did the transaction. So basically it's more ownership focused, and also is that it's basically consume less gas compared to ERC-20. So gas is the transaction. So the disadvantage and the risk right now is that it's basically one of the proposals, not a standard. So there are a lot of very few tokens which are there, I think almost negligible, which are using it in the production. So also, as I told you that the ERC-20 is compatible with current Ethereum standards. So if you want to get it, it's not any exchange or anything. It's like very, very easy using ERC-20 tokens. But ERC-23, the exchanges might have to do some modification and some things like that in order to make sure the compatibility is also an issue with ERC-223. And then the ERC-721 is like one of the hottest things I've seen CryptoKitties based on ERC-721. It is more like a collectible. So the main important ERC-721 is already into existence, like being adopted by a lot of people around. Is to create a non-fungible token. So in ERC-20 and 223 standards, we have a supply of tokens where tokens are fungible. That is, single token of that unit is equal to another unit, which means that there is no separate identity for each token. This makes it very easy to create those tokens as similar to other tokens. But what ERC-721 proposes is that each token is unique, each token is non-fungible. So basically the whole use case they want to focus is on arts and collectibles. Like let's say I have a Picasso painting, right? So that Picasso painting value is totally different from the painting of Da Vinci's or something like that. And this Picasso painting should be represented by one unique token, which is totally different from the other tokens. So on ERC-721, you can basically create the tokens. You can basically have you can differentiate the characteristics of one token from the another token. So similarly, one of the amazing use cases is like arts, because every art or painting has different value. Your valuables, because every value is different. So they have created an interesting collectible game called CryptoKitties. So certainly what happens is that, so basically in ERC-721, you can kind of differentiate one token from another because every token has their own characteristics. So they have one interesting game I was talking about, like CryptoKitties. So the whole idea is that one kitty is from another. So you can basically, since they can differentiate the characteristics, you have to play a game, you have to train your kitties, and the characters, as you advances the level of your kitties or your cats, like it's recorded, and the value of your token is also similarly increases because it's like a collectible. So you should check out CryptoKitties. It's like a really cool game, and I think a lot of the games are basically focused on ERC-721. A lot of sports game, like like Ronaldo is one of the most expensive players. So let's say if someone creates a token for Ronaldo, which become like a collectible thing, and collectible thing because they could be just only one Ronaldo token or one Ronaldo on the entire blockchain. So it's like a valuable. So it's like a very cool concept. So there are a lot of applications happening on ERC-721, and And basically the whole idea is basically to make sure that every token is basically different, because everybody has the different characteristics. So this is what about Ethereum is, friends, and I'm gonna basically, so this is our friend, I love crypto. He is beautifully explained about folks. I'm gonna also attach the link to his video, and I think it's exciting times and to see what's gonna happen. And keep following Snapper Buzz. And if you want to kind of reach out to me, and if you're looking for blockchain consulting, if you want to have your own DApp or your own chain developed, or you need any sort of thing related to blockchain, think Snapper, you know where to reach out to me. You can follow our website www.snapper.tech or snapperfuturetech.com. You can reach out to me via LinkedIn, on Telegram, and you can email me on prashant.surana@snapperfuturetech.com. Please comment below, and also, since I mentioned that you could basically earn free bitcoins, just comment why you love why you love Bitcoin, why you love Ethereum. Just comment below, and the most amazing comment and the most exciting comment at the end of part 25 blockchain series, or 25 episodes, at the completion of 25 episodes of blockchain series, have a chance to win $50 worth of free bitcoins. So keep commenting, keep engaging. Please do subscribe to our channel. Please do follow Snapper Buzz. Please do follow its analytics, and let us know what do you think. And this entire show, so just a disclaimer, just to add again here, this entire series is not about promoting any cryptos or anything. Investing in cryptocurrencies definitely has a very high risk. So I suggest to invest very, very carefully, very wisely. If you have any other queries, you can reach out to me. And it's really great to know that the moment we started talk about Ethereum, the signals are in the green. So it's really amazing, and I think we should keep doing great work to the community. We should keep supporting blockchain. We should educate people around us about the blockchain, why this technology is important, because I think it's going to create a lot of lives, it's going to create a lot of jobs, it's going to create lots of opportunities. So keep educating, and as I would always believe that let's educate before we innovate, and let's blockchain the world. So bye-bye, take care. Let me know if you have any doubts. Let me know if you need any help with your blockchain things, and just keep following and keep spreading the virus, keep spreading the blockchain virus. So thank you so much. Take care, and bye-bye. See you again. So our next talk's definitely gonna be our next blockchain series gonna be more focused about Ripple, because we have decided to move in the order of the top market capitalization of the coin. So we're going to talk about Ripple, and Ripple is one of the most exciting blockchains because it's basically trying to be the Swift of the payment space. So we're going to talk about them. We're going to talk about their clients, their partnerships, and also before we go, let's have a look at some of the most amazing quotes about what people say about Ethereum, right? So Brad Garlinghouse is one of the co-founders of Ripple, and also one of the largest Ripple holders. In 2017, he has commented that people have realized that there isn't going to be one crypto to rule them all. You are seeing vertical solutions where XRP is focused on payments, Ethereum is focused on smart contracts, and increasingly Bitcoin is becoming a store of value. So those aren't competitive. In fact, he wants Bitcoin and Ethereum to be successful because they are focusing on different problems. Then we have Roger Ver, which is also called the Bitcoin Jesus, and also one of the guys who led the Bitcoin hard fork to Bitcoin Cash. So if you look at the market cap of Ethereum before the hard fork and the split into the Ethereum Classic. So I mentioned that the Ethereum has split from Ethereum Classic. The combined market cap of Ethereum Classic is greater than the market cap before the split, and everybody got what they want. So he's also pretty much bullish about Ethereum. And Vitalik has also said that a lot of things. So Vitalik, you can see Vitalik posting a lot about Ethereum, and he has said that although the Ethereum blockchain is a public blockchain, it is great to see the private and consortium blockchain using the Ethereum code base actively under development. So as I said that Ethereum coding language is like really simple. It's based on JavaScript. It's based on lean stack. So you can basically use it, and it could basically use for a combination of a public and a private network, and a great solution for an on-chain and off-chain network. So it gives a lot of customization to the developers, based on to the developers, to the businesses, to you choose the logics, to choose the parameters based on their use case. Really interesting. So I'm going to post the links to some amazing quotes if you want to learn more about Ethereum. So this is some more about Olive Carlson V. So these all are like people who have commented like most successful entrepreneurs, most successful, key opinion leaders, and the guys in the space to definitely follow. Tone Wei is one of the most successful investors. So he said that a token like Ethereum has gone up 10 times faster than Bitcoin. So basically, in 2014, the Bitcoin, the Ethereum price was like about started at $1, the ICO, and it was trading at 10. In 2017, went to like $1,500, like 150 times in just like 3 years, right? Even Bitcoin didn't go like up like 150 times. So basically it's fueling an ICO bubble, no different than the .com 90s of the late 90s. So I've seen a lot of ICO waves coming where people are trying to raise money based on their ideas, based on the token model. But however, we have to realize that the currency is basically this has a lot of volatility. So any money which has a volatility which cannot be standardized definitely cannot be used in a day-to-day transaction. Is more like a speculative kind of thing. So just keep following, and I think Ethereum overall is a great blockchain. The most important advantage of Ethereum is that their computational infrastructure is GPU backed. So I think their infrastructure is one of the largest if you combine even with the AWS or the Microsoft of the whole world. And I think it's like personally undervalued. Just like being the one of the largest computational infrastructure of the whole world is still just had a market cap like $15 billion compared to Amazon, which has 800, Microsoft, which is around 900, and Apple, who is about $1 trillion. I think Ethereum blockchain is far undervalued, and I am in for it from a long-term perspective. Again, it's not investment advice. I am not an expert to advise you on this. If you're investing, invest on your own risk. So take care, guys. See you. Bye-bye. And it was actually great talking to you again. Take care, and just let me know. Keep commenting, keep sharing. Again, let's educate before we innovate. So thank you so much.